convinced that we wanted to do this training at my university, but we ran into a lot of obstacles and other considerations, namely crowded curriculum. Where would we fit an extra course into the curriculum? And having limited resources to offer such a program because it requires an instructor for a full course. So we thought about alternatives, and one of the things that we explored was, could we develop a program that students could do on their own, like an online program that students could do like outside of class time. It wouldn't take instructor time, it wouldn't take the class time. So next slide, please. And there would be some advantages to offering an online training. Low resource requirements. We could give a quick introduction during class and then have the students do the work outside of class. And we envision something that was like 30 minutes per week, not a real burden on the students, but would hopefully improve their spatial skills. Next slide. Okay, so this is a screenshot from the training program that we developed, and basically it allows the user to manipulate the object, to interact with the object on the screen and try to rotate it in different ways using the mouse and see what it looks like when you do different rotations of that object. There are a number of different types of exercises that are offered through the training program, but basically they all involve manipulating these objects to rotate them in space. Next slide. And there are some things that are unique about the approach. One is, so it has a theoretical foundation. It's based on Gestalt processing, which is the idea of rotating the object as a whole rather than thinking of it as breaking it down into parts. And allowing the user to manipulate the rotations, because that's been shown to be really effective in spatial skills training. It disrupts the fixed axis visualization, which is like thinking about fixed X, Y, and Z axes and rotating the object around those axes, but instead it allows the user to define an axis that can be moved around in space, and then you just do like one rotation about that axis to reach the target rotation. And it also provides scaffolded learning, so students who need a bit more practice, who are more beginners with spatial skills, can pick some problems that have some supports to make the problems a bit easier, and then choose more advanced problems as they move along. Next slide. So when we started doing our testing, we did see things that we had observed in the literature as well, that there is a robust gender difference in mental rotation ability. This has been shown through many studies using many different tests. We found that while 28% of the engineering students are women, about 50% of the students who failed the pretest were women. So they're overrepresented in the students who fail. Next slide, please. And this also shows pre-test results by gender. The x-axis should say gender, not ender. And of the men who took the test, 21% had weak spatial skills, and of the women, 51% had weak spatial skills. So just another way of looking at the gender difference in the pretest. Next slide, please. Okay, but we did see that the training closed the gender gap. Men and women who completed the training outperformed their peers who did not complete the training, and then the training helped to close that gender gap. Next slide, please. And this shows the effect of the training for all students, not just for men and women who had weak spatial skills. So substantial increases between the pre-test and post-test. The gain between pre and post is significant. And we saw a large effect size for the training. There's some literature that reviewed all different spatial skills training programs, and the average effect size for all training programs was 0.42, and our effect size was 0.85. So we were pretty pleased at the effectiveness of the training program. Next slide. So as we repeated the training over a course of 3 years, we made some changes to the system and the way we implemented the training. So after year 1, we incentivized the training. We did it in class, and the first year it was just a pilot thing, but then we saw good results. So we made it part of the class, and we made it part of the grade. So it represents 5% of the grade in the first year class. We saw slightly better results in year 2, but not significantly better. So we really can't draw any conclusions about making that change. After year 2, we made some changes to the spatial skills system, and these focus really on communicating with the students and letting the students sort of check their progress in a variety of different ways. So we built a dashboard. We had student and instructor reporting, so they could pull their data from the training. We had weekly progress reports that are sent automatically by the administrator to students, as well as weekly reminders for what they should be working on next. And with those changes, we saw significant gains. So some of our lessons learned are that communication and letting the students really check their progress and giving them a variety of ways to check their progress seemed to be really helpful. We saw that the students were engaging a lot more with the system instead of just trying to get the problems done. Next slide, please. So the recommendations from our experience are, there are a variety of spatial skills training programs out there. I think it's, there's good evidence that spatial skills are linked to academic success, and improving spatial skills can help students perform better and have a higher graduation rate. So I do recommend considering that offering some spatial skills training, especially to students who have weak spatial skills. And then choose or design a training program that works for your university, for your context, your curriculum, your resources, because there are a variety of options out there. And I think, if you offer credit, it does incentivize the participation. So we did see much better compliance with the training when we offered credit. Next slide. And this is the last one, just acknowledging the National Science Foundation and the grant that supported this work.
Student engagement in our course, whether it's online, whether it's face-to-face, has to be done by design. You cannot just by chance. So if you want